Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're starting with the introduction to the acids and bases. This is again we're doing the Unit C, Grade 11 Chemistry. Today's topic is start of the acid and bases, and we already done something about the acid and bases in the past few lessons. So today's topic is very important about the acid and bases. So let's start with some brief description and about the acids and bases. So acids. So acids from solutions that have the blue litmus toluene that turns blue litmus toluene are the acids, and they are the electrolytes too. And they neutralize the bases because acids neutralize the bases and bases neutralize the acids. And the bases turns red litmus to blue, and they are also the electrolytes. So that the difference I also have. And then we have a neutral substances. So neutral substances are from the solutions that do not affect the litmus. They didn't affect any litmus. They stays the same. And some of them are the electrolytes and some of them are the non-electrolytes. Basically, if you doing the pH thing, we also doing that in the later on lessons. In the pH, the acids are from the 0 to 6.9. Then from 7.1 to 14 we have a basis. At 7.0 we have here all the neutral things. Because of that they do not affect any of the neutrons. This is all about the empirical definition. But with the NS theory, so NS theory is again the theory we did in the next lesson. So you have to be like something introduction about there. So some hydrogen compounds ionize to form the H plus aqueous ions. And then H plus aqueous ions react with the OH, then they produce the water. So you have to know that acids can produce the H plus ions. And when we compare the H plus and OH, when they react together, you get the water. In the bases, we have a hydroxide ions, which is the OH negative ions. The bases can produce the OH minus ions. And when we compare OH with the H plus, they both react with each other, they will produce the water. In the neutral substances, because these are neutral, so H plus and OH negative ions cannot be involved in this, cannot be formed. Some are the ions in this, some are the molecules in this. That's why the neutrals can be stay the same. But we main focus on the acids and the bases for these lessons. For the lessons too. For that, you have to know that how to win naming or writing the formulas for the acids and for the bases. Bases are easy, but acids are some difficulty we have. So in the writing the formulas of acids, so to recognize an acid from a chemical formula, look at the hydrogen symbol. If they have a hydrogen symbol on the left paired with an ion on the left like this, so on the right we have like this and we have a left one like this. First, try to recognize this if they have a hydrogen symbol or not. While naming and writing the formulas of acids in their pure and molecular form, you have to be taking care of the solid liquid gas thing also. Follow the same rules you did with the name and writing formulas as the ionic compounds we did in the lesson. I don't remember, but we also did that too. That how can we deal with those? So the same steps can be measured in this too. When acids are dissolved in water, they are given an acid name and their state of matter too, which is aqueous. The acids, when they goes with water, they react with water, they will get the aqueous. And indicated that it is dissolved with water at that case. We also can take care of the IPOC naming in this. IPOC acid name is given by adding the aqueous to the beginning of the name. The beginning of the name will give the aqueous, so this is the IPOC naming. When hydrogen chloride HCl dissolved in water, it's called the aqueous hydrogen chloride. We say like this, aqueous hydrogen chloride. As I commonly have the classical acid naming too, like aqueous hydrogen chloride is also called the hydrochloric acid. This is called the classical acid naming. So we have full table for this, and this table you have to learn this. You have to memorize this table. So the pure substance name, if we have, so let's say some examples. Yeah, we have examples over there. So I can say with the examples how can we deal with this table. So we have to memorize this. Okay, we have to find the write the neat chemical formula for the chlorous acid. So for this type of acids, so we don't take care of in the these are not in the pure substance name. These are in our classical acid naming. Right over there. this. We have this thing which is chlorous acid. So in this, you have to go either that way or either that way. We have to make the chemical formula, so you can do either that way. So in this way, over there, or everything in the first you have to write the hydrogen. In that thing, you have to write the hydro in first, like they are different things. But in the aqueous name, you always write the aqueous at the first. They are related to each other. So if we break down this, your chlorus in this form can be written as the chloride, like this. And this has to be have been H plus thing because this is acid. So we have to write H first, and this chloride you can find from the polar atomic thing. This has this like formula is this. You can join it by this. Both has plus and minus they cut out, and this is aqueous, so this means aqueous. This point of view, I know this is something like tricky thing, and you have to like do practice in this, and then you have like a master in this. So provide a hyper name and classical acid name for HI. So HI is given in the pure name, like the pure substance name. You have to find for IPSC and the classic naming. For IPSC, this is HI, so we have to take care of the aqueous first, always in the IPSC. So this is like a hydrogen iodide in this thing. So write it like this: aqueous hydrogen iodide. So hydrogen, then we have a iodide. So that's how the IPSC naming works. And with the classical acid name, so in the isolated we have HI, and classical naming we have like a we have like a thing with the iod. We can deal with this is the acid, deal with the ic acid, which is IC, and we can deal the hydro too because this involves the hydrogen in this. If there is a hydrogen, so we can get rid of this thing. So it's hydrogen becomes hydroic, hydroic acid, like this. And last, chemical formula for nitric acid. Nitric acid NO3 negative, and this is H plus has to be at this acid, so we get HNO3, which is the strong acid too. That's how the acids naming of acids works, and you have to memorize this table for the acids naming and writing. Very important table, and you get one question for sure, one or two questions for sure in examination. The next thing is very like easy. Naming reactive formulas for bases, very easy. So formula for magnesium hydroxide, Mg2 positive. This is Mg2 positive. This is OH negative. You will get a MgOH2. This should be in solid. Done. Next we have a LiHO. Do the naming. This is the lithium hydroxide. This has a positive, this is negative, and we get. For the potassium hydroxide, same as magnesium. This is K plus, this is OH negative. You get KOH, but this time this is an aqueous. You can check the solubility chart to doing the like a aqueous, solid, or liquid, or gas. Then easy for bases, but for H you have to memorize this table. Very important. Very important. So that's all the introduction for the acids and bases. In next topic, we are doing the actual things, which is the NS theory. We do the modified NS theory, so which is very like a long topic, and we discuss that whole topic in the next lesson. That's all for this lesson. Let me see if EduVibe learns more, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till it's with EduVibe.